Well, good morning. It's Monday, the 20th of April. I hope you've had a lovely Easter break. I hope you haven't eaten too many Easter eggs, unlike myself, and I hope you're looking forward to doing a little bit of maths again. Now, if you haven't yet had a go at CorbettMaths Foundation, 5 a day, May the 3rd, I suggest you pause this video now and go and find that. The questions are in front of you and have a go at it. The questions that we'll be looking at are the front, side and plan view of the isometric shape first, then we're working through the product of prime factors, and then a ratio question, and then a factorized question. So as I say, if you haven't had a chance to look at these questions yet, please press the pause button now as I'm about to go through the work solutions to these. So let's look at the four questions that you've got to do. We've got to do 3 different views of this shape first of all. If we look at these isometric shapes, I've seen these taught a number of ways and I'm not convinced I know exactly the best way of teaching this. So I'm going to look at 2 methods if I can. The arrow should be donated with a front statement there, and that is where we are stood looking at that shape. That's how I always think about it. So we're stood looking at the front. So if you're stood outside your house and you're looking at your house, you're looking at the front of your house, and that's what I want you to try and visualize. So imagine your house looked like this. This could be maybe the chimney. What would we see? Well, if we were stood at the front looking, and this should normally be drawn on some gridded paper, so I'm going to do my very best here. You would have the 4 squares here that you could see, and then as I stated, you'd have the square above, which is like the chimney. So that is the front view. The side view would be from this side here, as if you're going down the side of the house, if you want to think of it that way, and that's known as sometimes the side elevation, as the front is known as the front elevation. What would we see if we walked down the side? You'll notice that they are perpendicular to one another, and the side is normally off to the right of the front. It's not a big thing, that's the normal convention that is used, especially in GCSE questions. So what would we see if we were stood here now looking at this building? Well, I hope you can see that we'd see that. We'd see this side edge here and the bit of the chimney again, if we're thinking that as the chimney. Now the plan view, you guys are very lucky these days because you have the internet and you have a number of things that we didn't have when we were at school. And one thing that's on the internet that I find very, very useful when teaching this is Google Earth. You see, it doesn't say this, but Google Earth in its true orientation before you hit the street view or you start to angle things slightly is plan view. So we could call this Google Earth view. So what would we see if we were looking down from the sky in a drone? Say if you've ever played with a drone and you've looked directly down from a perpendicular to the ground, what would you see? Well, I'm hoping you would appreciate we would see the 4 sections, and again I'm just going to shade that one in. That would be the chimney, if that makes sense there. So that's the top of the chimney, that's the square to the right there, 2 squares to the left there, and they're there. Now as I said, I've seen this taught a number of different ways in my teaching career, and one teacher I saw teach this did this. They actually used a different colour pen, and what they did was they actually labelled the sides and they labelled the front. Now I don't know if that helps or not, but every cube has a front and a side. A front, the side is hidden, front, the side is hidden, front, the side is hidden, front, and the side is there to be seen. And then of course you can put in the P's for the plan view as well if you really want to. As I say, I'm not saying that's the best way I've ever seen, but every cube there in that shape has a front, a side, as I say, given to the right, and a plan view. Now you're going to get a chance to have another go at one of these questions in a minute, so again, if you want to rewind the video and look at how we did that one, there is the solution to those questions there. So let's now look at the next question, and in the GCSE exam they would say write 60 as a product of its prime factors. So straight away you'll notice the word primes mentioned, which means we need our prime numbers 2, 3, 5, 7 and 11. And it is good to be able to recall your prime numbers as quickly as that literally 2, 3, 5, 7, 11 that fast, okay? And if you can't do that, that's definitely something worth practicing if you are in year 9, particularly if you're in year 10. So what we're going to do now is we're going to see which of these numbers are factors of 60. So they have to be prime factors, so it means they have to be prime numbers. What I always say to students is, just start with 2. Just keep this nice and easy. See if 2 goes into 60. So does 2 go into 60? Well, of course it does. 2 goes into 60 30 times. And I ask students to circle the 2 because that's a prime number. You can go to 2 again and say, is 2 a factor of 30? Well, it is. 2 goes into 30 15 times. At that point there, you'll notice that 2 will not go into 15. So I move to my next prime number and I say to myself, okay, well, does 3 go into 15? Does 3 go into 15? Yes, of course it does, and it goes in 5 times. Now 5 is also a prime number, so I can circle that as well. Now the instructions you were given on the Corbett Maths was that you had to write this in its index form. So let me show you what actually we have found here. We have found that the number 60 can be written with prime numbers only as 2 times 2 times 3 times 5. And if you multiply that out, 2 times 2 is 4, 4 3s are 12, and 12 5s are 60. So that generates 60. But we're asked for index form, so we've got to collect together our 2s, our 3s and our 5s. Now we've only got 1 3 and 1 5, but we have 2 of these multiplying together, and when anything multiplies by itself, we can say that it's squared, and that is the solution that Corbett Maths is looking for, and that I'm happy with that solution as well. Our next question on the Corbett Maths May 3rd sheet was to factorise 35w minus 45y. So we're now looking for common factors that we can factorise and divide out. So what is common here and what is common here? What can we divide out? We can see that both of these are in the 5 times table, and that happens to be the highest common factor. There's no point dividing by 1, for example. So we're going to divide 5 out and see what we're left with. 5 goes into 35 7 times, so we get 7w. 5 goes into 45 9 times, so we get 9y. So the solution we're looking for there is 5, open brackets, 7w minus 9y. Now in the exam, you could always, if I get my other pen again, I know I'm actually writing on my answer here. You wouldn't do this, you'd write it again, but you could always then expand that bracket and check what you get. So in the exam, rewrite it and check it again. Okay, so our final question that we had to work on May 3rd was this ratio question. So Alan and Beth are sharing 65 sweets in the ratio 2 to 3. If you've watched my video on ratios, you'll know that the first thing written here gets the first part of the ratio here, 2 parts, and the second person here gets the second, which is 3 parts. So Alan gets 2 parts and Beth gets 3 parts. And if you haven't seen my video on ratios, then look back on my channel and you'll see I did that, I think, 2 weeks ago. But if you find it, have a look. I think I left like a little thumbnail of it with the ratio on so you can see. So back to this question. There are 2 parts given to Alan and 3 equal parts given to Beth, and there are, as you can see there, 5 equal parts. So I now need to divide 65 into 5 equal parts so I can put them into the 5 equal parts. 5 goes into 6 once, remainder 1. 5 goes into 15, 3. I did that very quickly. I hope that was okay. I'm trying to do everything without a calculator, and whenever you're doing Corbett Maths, there's nothing that I've seen too much so far. I'll keep an eye, and if there's something I feel is calculator based, I will show that on the screen so you'll know whether I feel it is calculator or not. But that's definitely done without calculator. So 13 into there, 13 into there, 13 into there, 13 into there, and 13 into there. 13 into each equal part. You can clearly see 2 13s give you 26 sweets for Alan, and 3 13s give you 39 sweets for Beth. Remember, in the exam, again, there is a lovely check here. You take these 2 numbers and you total them, you add them back together. 6 and 9 will give me 15, carry 1, and there's 2 plus 3 plus 1 giving me the 65 there. So again, a lovely check-in mechanism there for you. Okay, so I've got some questions for you to have a go at now. So I'm just going to hopefully set up 3 minutes on the clock. If you need longer than 3 minutes, you can always pause the video so you get a little bit longer. So let me set up 3 minutes on the clock. There we go. So I've redone the questions for you. I've done a new, well, let me show you. So there's the questions for you. So you've got a new isosceles shape to have a go at there. You've got a new product of prime factors there. Let me just see if I can. Well, I can't seem to get the timer on today, which is a shame. So what I'll do is I'll just say if you can have a go at that now, and we'll give you 3 minutes on it now. I'll time it for you. So I think I have managed to get the clock working. Apologies that took a little bit of time to get working. There's your 3 minutes, and I'll work through them after this. So remember, if you need a little bit more time, press the pause button now. That's no problem at all, as I'm about to go through the question answers. So pause the video now if you need a little bit more time to work through these. Again, I'm trying to suggest that you do these without a calculator. But let's take you through those questions now. So again, I've marked the front there for you. So I'm going to therefore state that this is the side. And if you want to start with the idea of using colours, so this is the front, this will be the front, this will be the front. So that's looking at this building. I would see this, and I would see this, and I would see this. Another way you can do it is think of more arrows that are in the same direction. The side is coming from this angle here. So this would be side, this would be side, this would be side, this would be side. And then the shaded in ships there, the rectangles that have been shaded in, they may not be shaded in the exam, may make that very clear, and they are what we would see from the plan view. So if you like that way of doing it, you can label them up. You can do it in pencil. If you were worried about that in the exam, do it in pencil and rub them out. I don't think it's a problem to do them in pen, but speak to your teachers, obviously see what they think when you're doing this. So looking at the front here, you can see I would see these two rectangles on top of each other here. Again, this would be on gridded paper in the exam. The grid would be there for you to draw, so you don't have to worry about drawing rectangles. They would be identical then. And I would see this rectangle here. Very well done if you got that front and got that correct, because it's a tricky shape. I tried to choose. From the side, I'll have 1, 2, 3 in a row. And there they are. And then this one here would have one on top there. So if you think of the chimney being at the back of the building this time, there. And as I say, look at that little mistake there. That wouldn't happen in the exam because of gridded paper. Finally, that Google Earth view, that plan view, well, I'd have 1, 2, 3 there with 2 to its side. So I would see something like this. And again, if I just shade that one in, that's that one there, if that makes sense. And again, that's a clever way of doing it in the exam. If you shade one, and then you can use that as your marker point, and you can say, yes, that's the one that I can see there. And I can't see the square underneath, it's not visible. So very well done if you got those correct. Let's look at the next question now, and we were doing prime factor form again, so product of prime factors. So again, I need to know my prime numbers, 2, 3, 5, 7 and 11, and again you should be able to just reel them off that quickly. It's an even number, but 27 is divisible by 3. So it's up to me. I can half that straight away, or I can divide it by 3. And on this occasion, I'm going to divide it by 3, because I know 3 goes into 27 9 times. So 3 would go into 270 90 times. So it's up to you how you do this. And again, I can see 3 goes into 90, it goes in 30 times, and I can see 3 goes into 30 10 times. And now I'm left with 2 going in 5 times. Now if you started with 2 there and you got 135, that's not a problem. You probably then divided by 5 and found out that 5 went into 135 however many times. And that's okay doing it that way. But sometimes if you can just see that a number is easier to work with, go with it. So writing this out, I've got 3 times 3 times 3 times 2 times 5. So 3 times 3 times 3 would give me 3 to the power of 3. I can then times it by 2 and times it by 5. I do like to order them. I do like to have my smallest prime number and then my next smallest and my next largest and my next largest. I do like to order them. And if I don't have a 7 and I have an 11, that's fine. I don't write my 7 and I write my 11. But any combination of that, very well done. Our next question that I gave you to have a go at was factorising 56x squared minus 28y. So we're dividing here and we're dividing here. Now, the last time I did this, when we did our quick starter, I didn't really talk about the letters because neither was common. And the trap here that people will think is, well, it's x squared, so I can divide by x. No, you can't divide by x unless there's an x here as well. So I did that on purpose to just see if I could catch a few people out with that. If I did, and I did catch you out, I apologise, but I'm just trying to make it very clear. And I should have said it when I did the first bit, that if the letters are not common or there's nothing common in the letters, then you cannot divide because there's no common factor. So we're looking at 56 and 28, and again I've done this on purpose because they share some factors. 1 goes into both of them, 2 goes into both of them, 4 goes into both of them, but the number I'm looking for is 8. You've got to go for the highest common factor. Of course, if I just quickly check that, don't think 8 goes into 28, does it? No, of course it doesn't. So 8 isn't our highest common factor. So the way to check that, of course, is to think of 28 and go down our common factors for 28. Factors of 28, sorry. So 1 goes into 28, and it goes in 28 times. 2 goes into 28 14 times. 3 doesn't go into 28 because of 27. 4 goes in, and 4 goes in 7 times, I believe. 4 7s are 28. Had to just think a little bit on the spot when you're recording yourself on these streams. So they are the factors there. So which of these are common with 56? And hopefully you can see that it's 7. We're going to divide by 7. So 7 goes into 56 8 times. We've already said x squared isn't common here. And 7 goes into 24 4 times, and y isn't common there. So using 56 and using their factors of 7 and 8, I think listing them off, I think I should have done that first, to be honest, and then I could prove what was the common factor. So what I was trying to say there was that was common, that was common, that was common, and that was common. They were all common factors. We used the highest common factor. Our last question in this section was the ratio question, and this time I had 3 parts. I had Ali getting 2 parts, I had Beth getting 3 parts, and I had Claire getting 4 parts. 2, 3 and 4. If I add these together, 2 and 3 gives me 5, plus the 4 gives me 9. So there are 9 parts. So there are 9 equal parts. So I now need to divide 144 by 9. 9 doesn't go into 1. But 9 goes into 14 once with a remainder of 5. 9 goes into 54 6 times. And again, you could write out your 9 times table to give you a little bit of help there. I don't know if you've ever noticed, but if you put a 0 there, which is a bit sneaky really, I shouldn't put that there, you have no tens and 9 units, and then you have 1 10, 2 tens, 3 tens, 4 tens, 5 tens, and this decrements. I don't like sneaky patterns, I don't like tricks, but it is something that works for the 9 times table. And you might know the way of using your fingers to find the 9 times table as well very quickly. I was looking for 54, there it is, 1, 2, 3, 4, 5, 6 nines go in. So, these 2 parts both get 16. These 3 parts get 16. And these 4 parts get 16. So Ali gets 2 16s, which is 32 sweets. Beth gets 3 16s. So a clever way here is to think, well, I know that 2 16s are 32, so just to add another 16 on to give you 48. And Claire gets 4 16s, well that's 32, and that's 32, so that's 64. So very well done if you got 32 sweets for Ali, 48 sweets for Beth, and 64 sweets for Claire. Remembering that we can then add all them together. Right, last thing before we go, I did say this was non-calculator, but I do want to show you a function on your calculator that can help you check things afterwards. I do think this would be on a non-calculator exam. I don't think this would turn up on a calculator paper anymore. It used to a long time ago, but we're just going to do a quick check here with our calculator. I just want to show you a very quick function just before we go. And what you do is, with a Casio calculator, if you got one of these, is you type in the 270. So I'm just going to quickly type that in. So 270, and you've got to press equals to force it in, and there it is, it's forced in there. Okay, so the equals button, that forces it in there. What you can do then is you can use the prime factorial button, which is here, the fact, if you've ever wondered what that is. So you press shift and the time key, and there it is, 2 times 3 to the power 3 times 5. Of course, another way of checking it would have been to physically type it out, and you'd have got the 270 as well. So just a nice little check there. So if you want to set yourself some questions to do yourself, and some questions I would actually have a go at, I'd have a go at 320, 400, 640, and quite a difficult one there, 1080 as well. So if you want to have a go at a few more of them, there's a few more for you to have a go at. Okay, and you can check them with a calculator. If you want to press the pause button now, I'm going to type these into the calculator and I'm going to write out each answer very quickly for you. So if you press your pause button now, you won't get the answers. Okay, so final bit of today then. Let's hopefully you press the pause button, you had a go at these. Just going to press the factorial key to get each one. So that's 2 to the 6 times 5. That's 2 to the 4 times 5 to the 2. That's 2 to the 7 times 5. And that's 2 to the 3, 3 to the 3 times 5. Told you that was a tricky one, didn't I? See you on Wednesday, where we're doing some more Key Stage 4 work. I think we've been doing some circles work, so we'll be moving on maybe into some prisms. I'll have a quick look at what we're up to. So Wednesday and Friday this week, some more Key Stage 4 for you. And don't forget that a week today, so Monday the 27th of April, we'll be having a go at these questions here. We'll be having a go at the Corbett 5 a day for 4th of May, and there's quite a few questions on there. So we've got 2 simplified questions there for algebra. We've got to find the volume and the surface area of a cuboid, and then we've got to work out the volume of this prism here, and that's what we'll be looking at this week, so we can have a go at that. And then we've got increasing by 17%. I would say that is a calculator question there. And then we've got to match the expressions here, so a little bit of laws of indices. So for me, the only calculator question on there would be this, but I tell you what, if you can do that without a calculator, that's very impressive. Okay, so we'll see you in a week's time to have a go at those, and we'll see you Wednesday and Friday. Remember to stay in, stay safe, and help the NHS. But thanks very much for watching, and we'll see you on Wednesday.